Hi everyone. In this video I'm going to explain how to round to decimal places. So in the last video we were rounding to the nearest 10, 100, 1000 and just considering whole numbers, but in this one I'm going to show you what to do if we have a decimal point and decimal numbers. With these decimal places you see on the screen we could have tenths, hundredths, thousandths, tenths of thousandths and so on. Okay, so just do a very quick recap on rounding a whole number, so then I can highlight the main difference when we're rounding to a number of decimal places. So if we were rounding a whole number like 53 to the nearest 10, we look to our tens column, there's a 5 in the tens column just now. We want to decide is that closer to, so is this overall number closer to 50 or closer to 60? Those are our two options, it's 53 closer to 50 or closer to 60. The number after the column that we're rounding to tells us what to do. So the fact that that's less than 5 tells us we're closer to 50. So 53 to the nearest 10 is 50. Okay. If we had a number like 5.3, our process is really similar. We decide what we're rounding to, so we want to round to the nearest whole number. Where is our units? How many full units do we have before having to break in to these fractions and these parts that we have shown by our decimal places? So there's 5 just now. If I have 5.3, have I got closer to having 5 or closer to having 6? So for the same reason, the number after the point is less than 5. So rounds down. So I've got closer to 5. Key difference here is the fact that we don't add a 0. So if we think back to 53, why was it really important to add a 0? Why does 53 not just become 5? Why do we need to add a 0 there? So for 53, it was really important that when that 3 got rounded, say we were closer to 50, we had to add a 0 to show that the 5 was in the tens column. If I just wrote the number 5 without the columns written above it, you would think I meant the whole number 5, just 5 in the units column. So the only way we can show that 5 is actually in the tens column is by adding a 0. And then the decimal point would happen after the units column there, after the 0. If we're rounding a decimal number, 5.3 to nearest whole number is 5. The decimal point is already clear, whether we write it or not, because the decimal point happens after the whole numbers. So when I just say the number 5, you know that that means 5 in the units column. We don't need to specify the decimal point, and we definitely don't want to put zeros. Not only is a 0 not needed, a 0 would be incorrect. If we write 0.0, that is a different number to 5.3. It's not that one is more accurate than the other, they are different. 5.3 less accurate is 5. 5.0 sounds like a more accurate number. If you think about temperatures, if I said it was 5 degrees outside, that could be roughly 5 degrees. I could have a really accurate thermometer telling me 5.3 degrees, but I might just say to you it's 5 degrees outside. If I say it's 5.0 degrees, I've gone back to my accurate thermometer. That's a very accurate number. It's got that accurate tenths place value. It would just be a 0. 0 is a number just like 3 is a number. 5.0 is an accurate number, 5.1, 5.2, 5.3. If we make it less accurate, we just don't show that column at all. And there's no need to fill any places with zeros because we can see by the number 5 that 5 is in the units column. So, to kind of sum that up, the main difference rounding with decimal places is don't fill zeros afterwards, because when would you stop as well? Those numbers go on forever and ever and ever. You'll just be writing zeros for the rest of your life. The reason we did need them when we were looking at 53 was because without one, it looks like we're talking about 5. We need the 0 to show that the units had a 0 and the tens was the 5. Okay, that is the main difference between rounding decimals and rounding whole numbers. So I'll just do another few examples with you. If we have 2.9, round into the nearest whole number, the nearest unit, so 2 just now, number after it tells us what to do. It's 5 or above. So just like 29 would round up to 30, it's the same principle, 2.9 is going to round up. The difference, think back of temperature to give it a bit of context to make it a bit easier. If it was 2.9 degrees, I want to know what's that closer to. Is it closer to 2 degrees or is it closer to 3 degrees? It's closer to 3, but roughly 3. We've made the number less accurate now. So it's roughly 3. Don't say 3.0, that sounds like you mean it's exactly 3.0 outside. It's not. It's 2.9, we're saying it's roughly 3. There's no need for any more information because when we say 3, we mean that 3 is in the units column. All the information there is needed. Okay, if we want to round to a different number of decimal places, 5.24. This one has 2 decimal places, has a number of tenths and a number in hundredths. If we want to round to the nearest tenth or 1 decimal place, circle the one we're talking about. It's 5.2 just now, but we need to look at the place after to decide whether it's closer to 5.2 or closer to 5.3. Look at number after, it's less than 5, it's going to be close to 5.2. We deal with decimals a lot in our day-to-day lives, especially 2 decimal places, because that's how we write money. So if we think of this as £5.24, but you've only got 10 pence pieces and you want to know, well, what's it closer to? Is it closer to £5.20 or is it closer to £5.30? It's closer to £5.20. However, unlike money, if it was money, we always write 2 decimal places in our final answer, but if we're just rounding a number to 1 decimal place, we want to make sure you only write 1 decimal place. £5.24 becomes 5.24 becomes 5.2. Let's do one that rounds up. So I need to pick a number 5 or above. 6.79 to 1 decimal place. There's our first decimal place here. Number after is 5 or above. So we're going to round up. So 6.79 to 1 decimal place goes up to 6.8. Not 6.80. Even listen to the wording of the question. It said to 1 decimal place. Make sure your answer has 1 decimal place. Okay, once we understand that rule, we can apply it to any number of decimal places. So let's go for 0.3258. And let's round this one to 3 decimal places, or DPs for short. So I want 3 decimal places. Each place after decimal point is a decimal place. That's 1, 2. This is the 3rd decimal place. It's currently a 5. Same decision as always. Does it stay that or does it go up by 1? Does it stay as a 5 or become a 6? Number after tells you what to do. It's 5 or above, telling us we're going to round up. So 0.3258 becomes 0.326. Don't add a 0. We can see exactly what column everything's in as it is just now. And if you add a 0, you make it sound like you're giving a more accurate number. It wasn't a 0 there, it was a 5 and then an 8. We've made it less accurate, so keep it as a 6. Okay, that same number, I could round to a different number of decimal places. So let's say I want to take that same number and round it to 2 decimal places. I have to make sure I circle a number in the 2nd decimal place. This is the one I'm concerned about now. So 2 just now. Same choice as always, stay the same or go up by 1. Number after, it's going to tell me what to do. 5 or above rounds up. So instead of 0.32, I need to go up by 1, goes to 0.33. I didn't consider the 8 when I was doing that because the 8 is so small in comparison to the 5 that it's not going to make a difference in my rounding. It's just like in my last video I talked quite a bit about if you had thousands of pounds, 5,279 pounds. The 5,000s is so big compared to the 200s and then the 79. What 1,000 is it closer to? It's closer to 5,000 because there's only 2 hundreds after that. Doesn't matter what other wee pounds or any pennies or anything like that you're going to add. The further down your line you go, they're too small to make a difference. You only ever have to look at the one number after the one you're rounding to. Okay, I'm just going to do one final example. Let's make it one with 9s. 9's can be a wee bit more awkward because if we round up from a 9, then how can we make that digit bigger? What happens is it has a knock-on effect. If you think, how does the whole number 9 get bigger? It becomes 10. So we have 1 in the tens column now, filling a 0 in the units column. How does 99 get bigger? It goes to 100. So exactly the same thing happens with decimal numbers. Oops, it's a straight line. Let's go for and let's round to 1 decimal place. So going to 1 decimal place, that's my 1 decimal place there. Number after is going to tell me what to do. It's 9 or above, which means I round up. So I've got 3.9 but I want to go up by 1. The 9 in that column can't go up, it has the knock-on effect on the units column. What's the next number you can tell me with 1 decimal place above 3.9? And it's 4.0, just like the next number above 39 is 40. So we've got 3.9 becoming 4.0. This time the 0 is really important because there is exactly 0 there. Above 3.9 is 4.0. And the question said 1 decimal place, so we need to make sure we give that 1 decimal place in our answer. So 3.997 becomes 4.0. This is when people say sometimes, but isn't 4 the same as 4.0? Yes and no. One is, if in this case, 4.0 is more accurate than 4. Okay. If you have the exact whole number 4, yes, absolutely, you can put 0.000 as much as you like after it. But when we're rounding numbers, we don't have accurate numbers. They came from something else. Think of temperature. Okay, a really accurate thermometer here saying it's 3.997 degrees outside. If I round that to 1 decimal place, I'm still keeping it quite accurate, not as accurate as that. I'm saying it's 4.0, but I'm making sure it's clear in the answer that it's still more accurate than saying it's 4. If we just say it's 4 degrees outside, that would be it rounded to the nearest whole number. Okay, it's still not wrong, but it's more rounded. I want to make sure you're given the amount of accuracy that the question asked for, which in this case was 1 decimal place. Okay, so that is rounding to decimal places. I hope this video was helpful.